how do you optimize your PCR, and which are the factors? Let's look at those quickly. Here are the key things. We already mentioned, annealing is very important step. The second step next to denaturation. What is the annealing temperature is critical, and what's the time to get specific products. If you choose the wrong annealing temperature, two things may happen. What happens? What's one? Non-specific band, you may get lots of bands or a smear, non-specific amplification. Thank you, that's good. What is the other possibility? Opposite possibility. Nothing. You may not get amplification. So it's really a fine line. You have to define your annealing temperature correctly. Many times, great PhD researchers in the lab, I see that they just define, I use this annealing temperature. Why did you decide this? Either they say, oh, on these papers I used it. Okay, that's maybe you use the same primer, it might work, but that's okay. But you need to make sure that you use the correct annealing temperature, and we'll look at that. Your denaturation temperature is important. TAC polymerase, some people choose hot start to improve specificity. I think it's a good idea. I'm not sure, because either way we get good results. Whether hot start, hot start after you denature, you add your TAC, or you mix it in ice, you move it to your thermocycler. I think seems to be work okay. Enzyme concentration is very important. How much enzyme you added really contributes to if there is extra polymerase, that can sometimes specificity can occur. Magnesium chloride concentration is important. It's a cofactor. We'll look at that. Primer concentration and some co-solvents. So we'll look at some. Yes, question.
It's important to use a proofreading polymer DNA for
Okay. Okay, very good question. Is it important? The question is it important to use proofreading polymerase enzyme? Somebody help me answer. Is it for MLST or for anything? What's your question? For MLST purpose. What do you think? Help me. But you can answer it. Do you know that first, let's be clear. Proofreading polymerase versus non-proofreading. There is a recombinant versions of TAC polymerase, and there is a native TAC polymerase. There are some with a proofreading capability. Do you know what that means, proofreading? Okay, let's look at it quickly. So you have a given gene you are polymerizing. You have your primers. Okay. Typically, TAC polymerase attaches, and you will have magnesium cofactor, makes it functional, and then it polymerizes, right? I think all TAC polymerase has also exonuclease effect. If it finds something double-stranded, it chops that. So that is a typical one, and it's really polymerized. However, I think in my long version of the lecture, I have more details on that. Not on this one. However, there is a chance that TAC polymerase make errors. There is a chance, okay? That error, I have even the probability figure in the long version of the lecture I give at Ohio State, but let's say there is an A here, it may attach a C by mistake. It's not very high probability, I think it's 1 in 50,000, okay? So there is a cost to that. So you are doing MLST, you may get inaccurate results. You may think that, oh, I use MLST for this pathogen, 7 housekeeping genes, everything, but I see there is allelic profile difference on these 2 genes, while it could be an error. So, yes, absolutely, it is safe to use the proofreading. What is the proofreading? There is a TAC, a recombinant TAC, that polymerizes, and the way I understood it is it chops back again, it goes and checks its own work. It goes back again because it's got the polymerization and exonuclease activities, it cuts and continues. So that proofreading highly improves the accuracy or the fidelity of your findings. So So absolutely, if you have the option, I would say yes. Anybody who agree with me? Is that a good idea? Any suggestions? Okay. High fidelity tag has a proofreading. That's why we have to. Yeah, this is a sequencing. The question is yes, for any sequence. Yes, not just. So she gave example of for genotype, which is multi-local sequence type, which is it's a sequence. Yes. So for regular amplification, if your goal is to detect 500 base pair, you may not necessarily need high fidelity. If you have it, use it, that's fine. But regular tag, you amplify, even if there is error, you don't notice it, you get 500 base pair. But in sequencing, you want to know the correct order of the bases. Therefore, using high fidelity tag with a proofreading capability is very important. Okay, it minimizes your error. So that's excellent question. And we have some slides on the high fidelity and which high fidelity, I think I do have even some of that. Very good. Clear, everybody? Has any question? Okay. So PCR now, you have these various components. There are this temperature going up and down, and you've got this buffer, magnesium chloride, primers. It's a competitive process. Okay. So it's a push and a pull. You have the potential for non-specific amplification and the potential for getting a very specific amplification. Okay. So you have to really recognize that competitive process. Therefore, you have to balance all the factors, all the components, and the parameters you are dealing. Okay. Some of the things, buffer, which really maintains optimal pH for enzymatic activity. You need to give a due consideration for the buffers. Salts, optimum ionic strength, these are just theoretical things. You can read it. What kind of buffer do I use? What kind of salt, and all that is important. So now looking at factors affecting your specificity, one important thing is how much magnesium ions, magnesium chloride that you are present in your reaction. You want to balance that just enough for your TAC as a cofactor for your TAC polymerase enzyme. If you have the optimum magnesium, then you get specific products, nothing else, just the expected product. Okay, you see here the expected product, right? So that is typically in a range of 1 millimolar to 4 millimolar. And then in your reaction, if you are starting a new project, a new system in your lab, it's good to optimize what works best in your setting. Okay, you can play with it as compared to the other primer concentration, DNTPs, how much magnesium chloride is I would like to use in your setting. That's part of the optimization process. But it can range between 1 and 4. Okay? Typically, the amount of DNTPs, the components that you use, don't assume that if I have too much ACGT, it is not expensive, DNTP have plenty. If I add more, I get nice results. No, that's not a good idea. Okay? You want to use maybe even many times. I had at least a project when I was a graduate student, I was adding too much DNTP. I was getting lots of non-specific. I reached to the point that I just touched the pipette and put it in the reaction. I don't even pull 1 microliter. Just enough. I touched the pipette, put it in the reaction. That was just enough to pour in for my PCR reaction. But adding more is not necessarily a good thing. Okay, even adding less might be a good thing. But there is a recommended 0.8 millimolar of DNTP, and again for TAC, whatever you use within 1 to 4 millimolar. But again, you have to optimize in your setting. I could tell you more the range, but not necessarily that you use. So what happens if you have too low of magnesium chloride? There is no magnesium ions available for TAC. There is no cofactor attaching with TAC, no amplification. So you get nothing. That is clear. But you have optimum TAC, nice amplification. But if you have too much magnesium chloride, what happens, you tend to get, there's most likely you get several bands. Many, in addition to your expected band, you get non-expected band. So you have to make sure you optimize your magnesium chloride amount. Question? Okay. And then your primer concentration. How much primer is enough in my reaction is important. Again, there is a range from 0.1 to 1.0. Okay. If you use on the lower side, the specificity of your reaction increases. But you don't want to get too low. Of course, you need to have enough primers to have efficient thermocycling and polymerase chain reaction. If you have too much primer concentration, again, the specificity can be affected. The chance of your oligo primers to attach in a non-specific area will increase, again, being a competitive process. So you want to balance, again, what works for me, optimizing your reaction rather than just adopting from a wonderful scientist laboratory article. It's better when you start a new project, it's a longer-term project, it's better to optimize PCR reactions in your own setting. Annealing temperature, very important. Okay, what is the annealing temperature you use? We said earlier it varies, it depends, right? Okay, typically the annealing temperature you want to choose is just below your melting temperature. TM is the melting temperature of the primer. Okay. So if it is about 4 degrees centigrade or 2 degrees centigrade, you are good. It is good. It's the closer you get to that melting temperature, the more specific products you get. You don't want to get too close because if you reach to the melting temperature, it will never anneal. You will never get a product. Just below your melting temperature is important. If you go much lower, if you go 10 degrees below your melting temperature of the primer, again your specificity is compromised. There is a very high chance that you get less specific primers. Okay. So here are various potentials for mispriming. Poor primer design, we will quickly look at primer design. Magnesium chloride is too high, your annealing temperature is too low, or you may have pre-PCR mispriming, such as if you are not doing your PCR reaction, if you're doing it at room temperature in your tubes, there is, at room temperature there is some activities happen. So it's better to do it in ice or sometimes hot start aspect. Sometimes poor primer design, you may have some artifacts. The concentration is too high. All those factors can affect the specificity of your product, so you need to consider. Okay. So again, the bottom line, you have to look at your primer, magnesium chloride concentration to balance, your DNTP amount to balance, annealing temperature to consider in terms of optimizing your PCR. All those, at least the 4 factors I can think of, plus other factors, will be crucial in making sure you have a good amplification reaction. And then that affects your, if you're doing fingerprinting that involves amplification, all these factors apply. Some of the genotyping methods we'll look at in the next couple of days involve amplification plus restriction, or restriction plus others. So that's very important thing for you guys.